Hello everyone, welcome to Roman Just Codes. I'm Roman, and in this episode, I'll continue building our Flicky Home automation app. This time we'll be focusing on all navigation aspects of this application, starting by setting up nested navigation hooked up to our very own custom bottom navigation bar. Make sure to catch the previous videos in the series so you can catch up, or grab the link to the repo from the description for the full project. We'll be fleshing out the landing page, which will serve as the UI shell page around any of the matching routes for our home, rooms, devices, and settings page. When a shell route is added to the list of routes on GoRouter, a new navigator is used to display any matching subroutes instead of placing them on the root navigator. Nested navigation in Flutter is achieved in many ways. Since I'm using the GoRouter package, I'll be using a concept called shell routes. Let's proceed. I'll create the UI shell page, which will be called landingpage.dart, which will be a simple stateless widget that receives a widget via a constructor parameter called child. This is the common pattern used. Since I want to lay out my UI with the main content on top and the bottom bar below, I could use a column straight up, but I'm setting up the foundation of my responsive strategy, so I'll use a flex widget with a direction of axis.vertical. This is pretty much what a column is. Let's put a pin on this so you can see later how this plays an important role in my responsiveness strategy. Add the fed child widget inside an expanded widget so it occupies most of the real estate. We'll come back to this later to finish it. Go to the routes configuration in the app.routes file and define a shell route. Set the navigator key to be the one defined for this tab navigation, and a builder method which returns our UI shell wrapper, feeding into it the corresponding child widget from the matched route. Define all the subroutes for this shell route via its routes property. Remember that a separate navigator gets created, a widget that manages a set of child widgets with a stack discipline. In our case, we will define all the routes for the tab navigation, home, rooms, devices, and settings pages. For that, I need to have at least placeholder pages for each of those routes. Let's build them. Create the remaining features that will hold the corresponding pages, devices, rooms, and settings. Inside each feature, create the corresponding substructure for the presentation, create the corresponding pages. Once the core pages are created, let's create corresponding routes for them, shall we? Cool. So we have our shell route and the corresponding subroutes for each of our nested pages. This is the foundation of our nested navigation strategy. Whenever we want to activate one of the subroutes, we use the tabNav navigator key. If we want to refer to the root navigator, we'll use the main nav navigator key. Simple as that. Let's proceed with the navigation feature with the corresponding substructure. Let's create a poto class that represents a single bottom bar navigation item. I need an icon, a label, the route, and a flag whether the item is selected or not. I'll add a copy with method so I can keep these models immutability. Create the corresponding repository that will feed the list of bottom bar navigation items to our app. For the sake of this video tutorial, I'll create it straight up, but the recommended approach is programming to the interface, creating a definition of a contract that defines what this repository returns, so then we can implement both a concrete implementation and a mocked implementation for testing purposes. out of the same contract. This is great because RiverPod lends itself well for testability and for mocking. Return the list of bottom bar nav item models that will hydrate our UI. We'll need one for the home, rooms, devices, and settings accordingly. Populate their corresponding icon option and route, and by default, I'll have the first item with its isSelected flag set to true. Create a view model class that extends stateNotifier, which will manage as the state the list of bottom bar nav items, and maintain the state of which one is selected from the list. I'll create a method called selectedItem, which will capture the selected item from the bottom navigation bar, and internally it will handle the navigation to its corresponding route. With both repository and view model pieces in place, let's create RiverPod providers that will wrap their implementation. Create a provider type provider that just returns a repository that encapsulates the list of navigation items. In a more formal implementation, this could be swapped between a testable version and a concrete version. Create a provider type stateNotifier provider that encapsulates our bottom bar view model, feeding into it the navigation items fetched from the repository, also using its corresponding provider. This way, I can keep both view model and data source decoupled, and this could even come from a mocked implementation without this provider knowing about it, achieving true separation of concerns. With these providers in place, let's proceed and create the widget that will hold our custom bottom bar, which I'll call Home Automation Bottom Bar. I'll make it a consumer widget since I need a widget ref reference to read the relevant providers. Let's build out the structure. This will be a container wrapping a flex widget with a horizontal axis. Again, I'm setting the foundation of my responsiveness strategy. I want the child widgets to have space around horizontally. I'll consume the navbar items by using the map function to map each bottom bar nav item model to a widget structure that represents each navigation item, using an icon button widget as its core. Add some padding around the flex to give it some breathing room. Back on the shell landing page, add our newly created Home Automation Bottom Bar widget under the existing expanded widget. Looking good so far. Now let's make it do something. Upon pressing the icon button, we'll read the bottom bar view model provider, and from its notifier, tap into the available selected item method, passing the corresponding nav item. Almost there. Let me fix the routing so each nav item route points to the corresponding page. Now it looks good. Testing the theming real quick as a sanity check. Nice. Let's make these icons pop by reflecting the currently selected navigation item. Right now, they're all the same color. Let's do a simple logic to check whether the nav item's isSelected flag is true or not, and display the corresponding primary color out of the currently selected theme. Looking good on the dark theme. Flip it back to the light theme. Loving it. Let's wrap every injected child widget into the UI shell by wrapping it inside a safe area, just to be safe. Looks great. We're making great progress here, y'all. I mean, the bottom nav bar looks good, but you know me. I love giving a bit of flair to my widgets, even if it's subtle. I already have animations for each of my bottom bar items, each of which contains a corresponding light and dark theme. All I need to do is trigger their corresponding Boolean inputs of dark and light respectively to activate the animation for that theme. I created a slide animation for each of them, something subtle but noticeable. Let's come back to the code, and I'll create a shared widget for all my animated icon needs, which I'll call Flicky Animated Icons. I'll make it reusable enough so I can use it throughout my app with minimal effort. This widget will wrap the animated implementation of each of those icons using a stateful widget, using an enum as a reference to each corresponding Rive artboard and state machine. That way I can refer to these programmatically. Less error prone than if I use plain strings. While I'm at it, let's also solve the issue of knowing what size my icons will be. I want to have some predefined size to keep building my mini design system. I'll leverage the enhanced enums feature to return the corresponding size in pixels for each corresponding enumeration value accordingly. Back in our widget, pass both enum options for icon and size respectively. I'll create an additional flag called isSelected. This is what will drive whether the animation is already in the selected state, either dark or light, and if false, it will be in the idle state of gray. Let's build it out. Add the corresponding state machine and animation reference and a map containing the brightness to Boolean input mapping. Remember, we have a dark and a light Boolean input for each icon, not just the nav items, so this will work just fine. As always, in the init state, do the proper initialization, feeding as the artboard the enum icon name for both artboard and state machine. See how convenient this is? Each enum maps to the corresponding artboard and state machine in a programmatic fashion. All I gotta do now is populate my internal map with the found Boolean inputs. Yeah, you guessed it, from the brightness enumeration. Trigger a rebuild once we know the Rive runtime is fully loaded and animation is ready. Don't forget to dispose. In the build method, query the available brightness set at the system level, and if Rive is initialized, go ahead and flip the corresponding Boolean input to true to show the respective animation. Return a simple sized box wrapping the animation, using the provided size enum value we created earlier. Let's now go back and refactor the bottom bar nav item model and replace the icon option type from icon to a flicky animated icon option, the enum we created that maps to each of our Rive animated icons. Look how seamless it is. Just feed the icon option to our Flicky Animated Icons widget, the isSelected flag, and you're pretty much done. Take this for a spin. Nothing yet. It's because we are not taking into account inside our Flicky Animated Icons widget whether the icon is selected. Fix that and run it again. Boom! Animated icons in our bottom nav bar, like a Flutter boss. Is that still being used? I don't know. Anyway, without any changes whatsoever, they work flawlessly on both themes. Double boom! Wait, what did you say? That you also wanted more animated? Sure, why not? Use the Flutter Animate library, chain the animate method to it, and apply a staggered animation to each child, followed by a half-a-second sliding animation from the bottom. Flip it to the dark theme. Booyah! I don't know about you, but this is looking pretty slick already. Since we are in such a roll, let's tackle the side drawer widget, shall we? We'll build it off of the UI shell page as well, since all navigation pretty much starts from here. Let's add the core app bar and drawer as placeholders. Up to you if you want to leave it like this. I'm cool. But I'll show you how you can further customize them, and since you own every pixel on the screen, thanks to Flutter, might as well make it your own. Are you still with me? Let's do it. Remember, I have a drawer theme entry for each of my defined theme data instances for both dark and light. Let's start like we always do, by defining the model that will drive the UI functionality for this side drawer. Create a model called side menu item. I'll keep it simple, an icon, a label, and a route. Later I can further enhance it. As before, create a repository from which to feed the items. As mentioned, we'll keep it simple by creating it straight up, but my recommendation as always is creating an interface and implement a concrete and mocked version to increase its testability. For the sake of speed, I'll hardcode the values, but later I'll replace with their actual page routes and all. Create a repository provider and an additional layer of abstraction that reads the repository. Later we'll do a more formal implementation, but for now let's set up the plumbing. Create the widget that will house the side menu drawer widget itself. Out of the current theme, get the drawer theme, which you'll use to build a widget structure that reads the surface tint color for the icons and labels in this drawer. Back in the UI shell, let's start by replacing the default drawer widget with our newly created one, so we can test it in place as we develop it. Add some padding all around it. Flip the theme. It's picking up the right colors and all. Nice. Continue fleshing out the navigation portion of the side drawer by adding a consumer widget around the portion of this widget that we know may need rebuilding for sure, the drawer menu items. I could have made the whole widget a consumer, but why rebuild the whole thing when it's just the items that will change? Use a column layout and reach each of the side menu item objects from the corresponding provider. I'll use a text button widget so I can leverage the material style from it and the tapping capabilities, and lay the inner children horizontally using a row widget. Looking really nice. Wait, did I hear you say you want them animated as well? Well, look who likes animation now. Sure. Let's again use the Flutter Animate package, do a staggered animation applying an interval with a half-a-second sliding animation from the left, followed by a fading transition. Look at all we've done in just a brief period. Now, to top things off, pun intended, let's work on the top app bar. I mean, this works, but this doesn't align with our app's branding, so let's fix this. In the navigation feature, create a new widget called Home Automation App Bar. In order to serve as a replacement of an app bar, it must implement the preferred sized widget. Keep this in mind. Implement the required method preferred size, which returns a size object. I'll use a predefined value that I have from my styles. Now for my build method, I can return an app bar. Use the secondary color from the current theme's color scheme for the icon theme with a transparent background and no elevation. As the title, I don't want any text. I want an animated icon. Hey, the flicky animated icons widget we created earlier came in really handy now. Nice. Center the title widget in the app bar, and let's set the stage for future actions in our app bar. I'll add a notifications icon here for now as a placeholder. Test it with both themes and make sure things are looking as expected. Loving the way it's coming out, and you were able to witness how we accomplished big ticket items in our application, which were nested navigation, bottom bar, top bar, and side drawer, all by adding our own style to them. In the next video, we'll focus our attention on the nested pages, starting with the home page widget, in which we'll flesh it out fully as we make progress on our app. I mean, we need to land our user somewhere, so this experience is crucial. See you on the next video. Hey there, I am Roman from Roman Just Codes. I hope that you found the content of this video very useful, and if you did, make sure to like it and subscribe to this channel. You know subscribing to this channel is free, right? Thank you so much for watching.